My name is Kareem Khalifa, and our question today is, what is logic? In order to answer the question, what is logic, we'll proceed in two steps. First, we'll answer the question, why study logic? Then we'll talk about how a specialized language facilitates this study. Let me provide you with 3 reasons for why you should study logic. First, it will make you a better reasoner. Second, and closely related, it will make you a more critical inquirer. And third, and perhaps most importantly, it will make you a better participant in public discourse. Let's discuss each of these in turn. At root, logic is concerned with distinguishing good from bad reasoning. Let's look at a simple example of each. Consider the first argument. If littering increases risks to innocent animals with no clear benefit, then littering is bad. Littering increases risks to innocent animals with no clear benefit. Therefore, littering is bad. Now consider a second argument. There aren't many things that are universally cool, and it's cool not to litter. Matthew McConaughey would never do it. Although both arguments are telling you not to litter, the first is providing better reasons than the second. But what exactly makes those reasons better? That's something we're going to try and figure out in this course. Let's consider the second reason for why you should study logic. It will make you a more critical inquirer. Critical inquiry is the process of considering a statement, whether that be an aesthetic judgment, an ethical position, a scientific hypothesis, what have you. Then you take stock of the best arguments for that statement, the best arguments against that statement, and using the tools of logic you can critically evaluate those competing arguments to come to a considered judgment about that statement. This permeates the liberal arts, and so taking logic seriously can really influence everything that you do as a student. The third and final reason that you should study logic is the effect it has on you as a public citizen, your ability to engage in discourse with others. A huge part of what we'll be learning about in this class is how to carefully reconstruct someone else's ideas. And think about that. That's a profound form of intellectual respect. Right? When you do a reconstruction well, right, you portray someone else's thoughts as based on plausible assumptions and good reasoning. By contrast, consider the disrespect we typically feel when someone else fails to reconstruct our own thoughts in a charitable manner. No one likes to be treated like an idiot. You know what's really interesting about this is when you reconstruct your own ideas then, that means that you're paying yourself a certain kind of intellectual self-respect. But the crucial point is, whenever you see an argument, give it the best run for its money because that makes everything better for everyone. Right? You understand stuff better, people feel respected, and that's crucial. Now I want to talk about the relationship between language and logic. I'm going to do this in 2 steps. First, I'm going to distinguish between artificial and natural languages. Then I'm going to explain why we use an artificial language to study logic. Let's start this discussion by distinguishing artificial from natural languages. What you see below are some examples of the artificial language that we'll be working with, which is called first-order logic. Don't worry about understanding the symbols right now. That's not what's crucial. What I want you to understand is why it's artificial. Quite literally, it was designed. And it was designed to be as unambiguous as possible so that we can execute that central function of logic, which you'll recall is to distinguish good from bad reasoning. Let's contrast first-order logic, or FOL as we'll call it, with the natural languages on the right-hand side of your screen. Languages like German, English, Chinese, Spanish, Arabic, and so on and so forth. Natural languages weren't really designed in any strong sense at all. They emerged through rather haphazard and often unreflective cultural processes. As a result, they have all sorts of ambiguities. So there's an interesting trade-off then between the artificial language, FOL, and the natural languages. The artificial languages are excellent tools because they're unambiguous and because they're precise for the chief function of logic, which is ascertaining good from bad arguments. Okay? But they aren't nearly as expressive as the languages that you normally speak in, right? You wouldn't want to write a sonnet, for example, in first-order logic. So if FOL does what it's supposed to do, it will be an artificial language that allows us to discern good reasoning from bad reasoning more effectively. But ultimately, we want to be able to apply this back to natural languages. After all, that's where we have most of our arguments. That's where we do most of our reasoning. So how do we bring the lessons from this artificial environment back to reasoning in the wild? Let me offer an analogy. A weight room is a highly artificial environment. You'll never see LeBron James, for instance, carrying dumbbells in the middle of a basketball game. Nevertheless, everyone recognizes that athletes who put in quality work in the weight room end up doing better on the court by and large. Same thing applies to logic. FOL is an artificial environment. It's a weight room for your mind. But if you work out hard there, right, you're going to be better when you start debating the pressing issues of the day. So work hard, and you'll see your reasoning improve. So let's sum up the key points from today. Studying logic just makes you awesome. It makes you a better reasoner, a more critical inquirer, and a better participant in public discourse. You should do this. And an effective way to become awesome in just these ways is to use an artificial language called first-order logic, or FOL. Thanks, and I'll see you at the next session.